Solving a system of inequalities by graphing. There are three basic steps to this type of problem. Number one, place both inequalities in slope-intercept form. Slope-intercept form is y equals mx plus b, where b is the y-intercept and m is the slope. Step two, graph both inequalities. And three, the solution is the shaded area that is common to both. So let's do an example. We have two inequalities. We have 3x plus y is greater than 4, and x minus y is less than or equal to 8. So let's take the first inequality. Step one is to place it in slope-intercept form. So we want to isolate the y on the left side of the inequality. So we have to subtract out the 3x. 3x minus 3x is 0, leaving us with just y on the left side. Whatever we do to the left side, we also have to do to the right. So we subtract 3x from the right side, which gives us negative 3x plus 4. Okay, so that's in slope-intercept form. Now let's go to the next inequality. We want to subtract x because we want to isolate this y, so we subtract x from this side. X minus x is 0, leaving us with negative y on the left side. Whatever we do to the left side, we have to do to the right. So let's subtract x from the right. We have negative x plus 8. Okay, we have to get rid of this negative sign, so we divide by negative 1. Of course, we have to divide the right side by negative 1. These negatives cancel, leaving us with y on the left side and greater than or equal to. Notice the inequality sign changed from less than or equal to greater than or equal to because we divided by a negative. So now we have negative x divided by negative 1 is x, and 8 divided by negative 1 is negative 8. So now this inequality is in slope-intercept form. So step 2 says to graph both inequalities. So let's start with the first one. Y is greater than negative 3x plus 4. Okay, the y-intercept is 4, so we start at the origin. We count up 4, 1, 2, 3, 4, and this is the point where this inequality will intersect the y-axis. The slope is negative 3. The negative tells us that as we move from left to right, the line is going to be going down. The magnitude of the slope is 3, which is the same as 3 over 1. The numerator, which is 3, tells us how far we move in the y direction. The denominator, which is 1, tells us how far we move in the x direction. So again, negative 3 tells us we're going to be moving, or the line will be sloping downward, and we go down 3, 1, 2, 3, and over 1. Down 3, 1, 2, 3, and over 1. Okay, so now we can sketch the line. Now, when we sketch it, do we make it a solid line or a dashed line? We make it a dashed line because it says y is greater than. That means the solution is above the line. It does not include the points that lie on the line. If it were greater than or equal to, then we would draw a solid line, because the solutions include all the points that lie on the line. Okay, so this will be a dashed line. So we draw a dashed line. Okay. So y is greater than negative 3x plus 4. So we have to shade the area which is above the line, since it's all values of y that are greater than this inequality, this line. Okay, so let's shade everything above the line. Okay. So now let's graph the other inequality. It's y is greater than or equal to x minus 8. So the y-intercept is negative 8. So we start at the origin and count down 8. 1, 2, 3, 4, 5, 6, 7, 8. We know that the line is going to intersect right there. The slope is positive 1, or 1 over 1, right? So since it's positive, we know the line's going to be sloping up as we move from left to right. And since the slope is 1 over 1, we go 1 in the y direction, 1 in the x direction. 1 in the y direction, 1 in the x direction, and so on. Now that will be a solid line since its y is greater than or equal to. So we can sketch that line. And we shade the region above the line. And where the shaded regions intersect, which is where it's green, that's where the solution to the system of inequalities lie. So the green area is the solution. I hope that helps.